All right, we've been talking a lot about direct variation, and direct variation is a proportional relationship. Inverse variation, though, is a little bit different. In inverse variation, y equals k divided by x. We could also rearrange that equation to say that y equals k times x. So now if you remember, direct variation, we've worked with this for a long time. In direct variation, y equals k times x. Or k equals y divided by x. So the one we're working with today, though, right here, y equals k divided by x, as opposed to um, y equals k times x. Here we go. Describe each equation or graph in examples A through D as inverse variation or direct variation. Okay. A is direct variation, just quite simply. That's direct variation. That's the model I just gave you on the previous page. So if your constant of variation is always y divided by x, then that's direct variation. But if your constant of variation is always x times y, we call this direct variation. Just a memorization thing, unfortunately. There's no other way to go about this besides just memorizing the fact that this is direct variation and this is indirect variation. Okay, now here's what the graphs look like. Okay, with direct variation, and that's what C is, and we should know that, we've got a straight line that goes through the origin. So C is direct variation. Okay, and K divided by, sorry, Y divided by X is always the same thing. So we have a constant slope. That's why that's happening. K has a constant slope. Now over here on D, this is what a graph of an indirect variation looks like. And it will always look something like this, a curve that's kind of approaching x or approaching some number and getting closer and closer to it, but it never really actually touches it. Um, we'll get more into that here as time goes on. So here we're being asked to determine if the variables in tables 1 and 2 are inversely proportional and explain how you made that determination. Well, if they're inversely proportional, then x times y should always equal the same thing. So k equals x times y. So in 1 times 6 equals 6. 2 times 3, that also equals 6. And 3 times 2, that also equals 6. So this is an example of inversely proportional relationship. So these values of x and y are inversely proportional. Let's see if that holds true here on E2 or part 2. So they're inversely proportional because x times y always equals the same thing. That's k, a constant of variation. Okay, on part 2, again, x times y should always equal the same thing. We've got 1 times 3, that equals 3. And then 2 times 2, but that does not equal 3, it equals 4. So since it doesn't equal 3 every single time you multiply m times n, this is not inversely proportional. It's not inversely proportional because m times n does not always equal the same thing. Now, if something is inversely proportional, it's never going to be direct proportional, either direct variation. Example 2 here, we could check to see if 3, to see if this maybe has direct variation. 3 divided by 1 is 3, but 2 divided by 2 isn't 3, so it's not direct variation either. Next, if it takes 3 people working at an equal rate 5 hours to complete a job, how long would it take 5 people to complete the same job? Now, some people might set this up like this. They might say, okay, 3 people, took them 5 hours, so 5 people, it should take them X hours. And they'd go 3 times X equals 25, and X equals 8 1/3 hours. But, let's think about this. If there's more people, shouldn't it take them less time? Okay, so someone that set this problem up like this would be thinking that there's a proportional relationship. This is not a proportional relationship. It's not direct variation, okay? The more people you have, the less time it takes. That's what indirect variation is all about, or inverse proportionality. So this is not direct proportionality. So here's the way we need to set this up. Y equals k divided by x. So let's look at it as 5 hours for 3 people to complete the job. So it's taking, if we multiply both sides by 3 here, we get that k is 15. So the constant of proportionality, or inverse proportionality in this case, is 15. So now we can make a new equation. We could say y equals 15 divided by x. Now, y was our hours, 5. X was our number of people, 3. Now our number of people is going up to 5. So to figure out how many hours y, we'll take 15 and we'll divide it by the fact that we have 5 people now. And that'll tell us that it takes 3 hours for 5 people. Feel free to watch that example again. The volume of air in a balloon and the air pressure in the balloon are inversely proportional. If the balloon is squeezed to 1/2 its original volume, by what factor does the air pressure decrease? This is really not that bad. They give us the scale factor is 1/2. If it's inversely proportional, then the air pressure is going to increase by 2 times as much, because you just take the reciprocal. So if they were directly proportional, then the scale factor would just remain the same. But since they're inversely proportional, you take the reciprocal of the scale factor, and you're done. All right, that's all I've got for you today. It gives us a little bit of a start on inverse variation, or inverse proportionality, and we'll kind of talk about that more, and we'll add pieces to it. Have a great night, and I'll see you tomorrow.